Welcome to this module, and if you have seen the last module what we are looking at? We are looking at the loading effect, and we have seen the potential divider, we have seen an inverting amplifier, we have seen the output of the potential divider, and we have seen the output of the inverting amplifier. This particular module is to understand further the loading effect. That is why if you see last module, this module and the next module, you will have just the same aim with different parts, alright, same aim with different parts. Aim would be to study the effect of loading and input impedance, but part would be different, alright. So, this is the for part 1 which we have studied in the last module, and let us see when we integrate this both, when we integrate this and this, what happens, alright. So, this is the circuit. What is the circuit? That we have now potential divider, we have this potential divider which is this circuit, we have inverting amplifier which is this circuit, and we have to integrate it. That means, the output of the potential divider, the output of the potential divider is the input to the inverting amplifier, right. The output of the potential divider is the input to the inverting amplifier, that is the case. Now, to understand this, what is the output voltage and what is output voltage V out 2, first is we have to understand what is V out 1 and V out 2 when we connect it in this particular fashion. To do that, first is connect V out 1 to V 2 as shown in figure 7. So, if you see this figure, what is that? We have to connect the V out 1, V out 1 is this one, to V 2, V 2 is this one, right. So, we are connecting V out 2, V out 1 with V 2, done. Then apply 2 volts DC power supply at V 1, we are applying 2 volts DC power supply at V 1, done. Then observe and note down the output voltage V out 2. So, when I apply input here, I have to observe output V out 2 here, alright, and compare the observed output voltage V out 2 with the expected theoretical value. So, I have to just use V out 2 and expected output. I am not worried about this, because now I am directly connecting V in and V out, alright. So, this is the experiment, you can ignore this column if you want, if not it is similar column to the last one. So, it becomes easier for you when you perform the experiments, that is why I have kept the similar kind of table, alright. So, the point here is that now instead of measuring the output voltage at the potential divider and then separately measuring the output voltage at the output of the inverting amplifier, here what we are doing, here we are measuring the output voltage at the inverting amplifier directly, and the input voltage is applied at the input of the potential divider, that is what we are doing, alright. So, let us perform the experiment so that we understand what is a change, what is a change. So, you have to connect the circuit as shown in the screen, right. This is the circuit, remember, right, do not do any mistake, it is very easy. You are applying voltage across. So, even it is written like this, right. If I directly take a resistor, let us say I take a resistor, 2 resistors, I ground it, right, I apply voltage plus 2 volts, this is potential divider when I am measuring the voltage across this resistor, alright. So, do not get confused if you see circuits like this or if you circuit like this, because this is when you apply plus 2 volts, this plus 2 volt is with respect to ground, that is why you see always plus minus like this, alright. So, this is also potential divider, it is also called voltage divider. So, let us see when we connect the circuit, this is one which is easy, the inverting amplifier, the non inverting terminal is grounded, this is another way of showing ground, this is another way of showing ground. So, do not get confused if you have circuits like this or the another. If you want to go in detail, every symbol has its own perspective, its own understanding, but we are not interested right now to understand what are the symbols. You just assume that this is the symbol for ground, this is ground, this is ground, this is plus VCC, this is VEE, right, minus 15 volts plus 15 volts applied across the op amp. Inverting terminal is connected to the output of the potential divider. Resistor R4, resistor R3, R3 is 1 kilo ohm, R4 is 100 ohm, that means gain of this amplifier is nothing but 10, right, 10 is a gain. So, gain of this inverting amplifier is 10, alright. Now, let us connect this circuit, and if you see again Suman is there to help us. If you see the DC power supply and the breadboard right. So, he has applied the voltage to the input of the potential divider here, voltage at the input, right. How much voltage he has applied? You can see 2 volts here, correct. So, 2 volts he has applied at the across the potential divider, Now, this is the output, of potential divider that he will connect at the input of the inverting amplifier. So, now if you see, this was the inverting amplifier, right. If you can see clearly, it will be helpful. Yes. So, this is the inverting amplifier, right. What he has done is, he has connected this one, which is the output of the potential divider, to the input of the inverting amplifier, alright. Now, what we have to measure? What is the output of the inverting amplifier? So, output voltage he has to measure from here with the help of multimeter, and we will see what is the output voltage. So, now the input voltage is 2 volts, input voltage is 2 volts. For 2 volts, I think we will see the clipping. I do not know, we may not see, because 2 volts is will give us 1 volt at the output and 1 volt when we have a gain of 10. So, our output should be minus 10, right. We will not see clipping, because 2 volts is not given to inverting amplifier, 2 volts is given to the non inverting to the potential divider, and what we see is minus 1.689 volts. That is because okay, that is the output at the inverting amplifier. This is the output at the inverting amplifier. So, let us write down here, we apply V1 2 volts, V out 2 equals to 1.688 volts, alright. So, this is and it is minus, because it is a inverting out. So, what is the input at V2? Let us see what is the voltage across V2. So, we are measuring now the voltage across V2, and we see it is 1.006 volts, 1.006 volts, alright. So, this is the output at the inverting amplifier. Okay. So, this is one way of doing it. Let us do another way. Let him apply 0.5 volts at the input, 0.5 volts at the input. Okay, 1 volts, alright. Let us apply 1 volts at the input, so that we can see the output at the potential divider would be 0.5 volts. The output of the potential divider 0.5 volts, right. So, we are applying 1 volts at the input, 1 volt at the input, output at the potential divider 0.5 volts, or V2 would be 0.5 volts, right. Now, let us see V out, 0.853 minus 0.853 volts, right. So, if you see, right, what is the gain? Gain is 10. That means, if I have V2 of 1 volts, my expected output should be minus 10 volts, right. If I have a V2 which is 0.5 volts, my expected output should be minus 5 volts, right. But what is my output? my output is minus 1.688 volts, my output is minus 0.853 volts, right. Let us do one more experiment, all right. For one more experiment, let us apply uh, 0.5 volts in the input. Maybe we are doing something wrong. So, I am trying one more time. Let us say 0.5 volts. So, we have applied 0.5 volts at the as the input to the potential divider circuit, voltage across the potential divider circuit, and we are measuring the output voltage 252.5 millivolts. V out 2, V out 2 is minus 2 or 252, is it V 2, V out 2, right. V 2, V 2 is 252 millivolts. What is V out 2? Can you measure V out 2? V out 2, when we measure, the value is, if you can see on the multimeter, the value at V out 2 would be minus 0.419 volts, minus 0.419 volts. Now, again it is strange, is not it? Why? Because 252 millivolts, if I have a gain of 10, then 252, right, or 2.52, let us say 252 millivolts, that is like this, is easy. 252 millivolts into 10 will give us minus 2.5 volts, minus 2.5 volts. What I am observing? Minus 4.19 volts. There is something wrong with the circuit. There is something wrong with the circuit, is not it? Because what we are giving is input as 1 volt, our output should be minus 10, but we are getting 1.688. If we are giving input as 252 millivolts, output should be minus 2.5, we are getting output as minus 0.419. So, what is wrong? Is the circuit wrong? What we can think? Is the circuit not behaving properly, or our connection is wrong, right? No, the answer is not. The circuit is correct, right, but here we are looking at the loading effect, right. This is how the loading effect will work. Because of the loading effect, the expected output and the actual output will have so much of difference. This is what I wanted to convey in the lecture, and then now we can see in the experiment also that when we connect two different circuits, there is a loading because of the second circuit on the first one, or the output of the second circuit will not be equal to the expected output because of this particular loading effect. So, now we will see how we can remove this loading effect in the following module. Alright. So, what you understand is, when you take a potential divider, when you take a inverting amplifier, if you integrate it, the expected output will is not actual to your experimental output, right. This is your loading effect. So, let us see, this is a short module to understand what is the loading effect. Now, let us continue the next experiment in the next module, alright. By that time you take care, and I will see you in next module. Thank you.